Hey friends, I'm here to give you a little review on some naming compounds because I know some of you are getting them a little mixed up, so I want to make sure we get on the right track. First off, we're going to just go through naming ionic and covalent compounds. We're not doing acids or hydrates or bases at this time. So first off, how do we know the compound is ionic? The biggest hint is you always look for the metal. You will have a metal listed first for your ionic compound. The metal is always listed first if there is a metal in a compound. Just a reminder, the metals in the periodic table, you have the metalloid group over here that's in this like pink coral color. The rest of the periodic table to the left are metals. So you'll see that in the blue color. You'll also find that an ionic compound will always have a metal with a nonmetal or a cation with an anion. And essentially that's the same. The reason why I say cation and anion is because sometimes you have something like ammonium, which is NH4. And so you're thinking that's not really a metal, but it behaves like a metal because ammonium is NH4 with a plus charge. So it does have a cation, so it is donating electrons. How do I know if the compound is binary or ternary? So what you have to do is you just quickly count the number of elements in a compound, not the number of atoms, the number of elements in a compound. So if you're looking at just a chemical formula, you can basically count the capital letters. Be careful though, because sometimes remember like chlorine, when we write Cl, oftentimes that looks like I. So you just have to recognize that. Sometimes I doesn't have the bars on the ends, and so I just looks like that. So you do have to recognize that. So you have to see what that L potentially could be with. Or you can look at the suffix. So for example here, we have NaCl. So we're like, hey, there's one element, two elements. So that's binary. We have calcium and iodide. That's two elements. So that's binary. This one we have calcium, carbon, and oxygen. That one would be considered ternary. Or this one we have potassium, nitrogen, and oxygen. So that would be considered ternary. If we were looking at it from the standpoint where it was already written, we would see sodium chloride. Noticing the chloride, we would know that's binary. Calcium chlorate. With that 8, we know, hey, we need to go look at the back of our periodic table and think of a polyatomic. So that's going to be ternary. Calcium chloride, again, the ide is binary. And potassium nitrate, notice that 8, that's going to be ternary. Other endings for compounds could be ite. Could be, there's a couple that end in ide, but you cannot find them on your periodic table, and that is cyanide and hydroxide. And those two, although they end in ide, they are still polyatomic. Those are two common ones that end in ide as they're polyatomic. So binary ionic compounds, how do you name them? Well, first you name the metal, and then you name the nonmetal's root and add the suffix IDE. So let's do a couple of examples here. So if we name the metal, let's just say we have aluminum oxide. Okay, so we look at Al2O3, we name the metal, which is obviously aluminum, because remember, aluminum behaves like a metal. And then we use the nonmetal's root, which is ox in this case, and add the suffix IDE. Okay, very simple. This is the stuff you guys have been doing for quite some time. When you have to identify the formula, you have to do the charges for ionic compounds. So let's say, for example, I have Ca and N, and I want to put these two together, and I'm going to have to look at the charges. So I have a +2 on my calcium and a 3- on my nitrogen. Then I crisscross applesauce. So I bring my numbers down, not the charges. So then I would have Ca3N2. Simplify to lowest terms if necessary. Oftentimes without a transition metal, this is not necessary. But for example, if I'd have a 4 and a 2, I would want to simplify to lowest terms on my ionic compounds. For a ternary ionic compound, to name it, we're going to first write the metal or the polyatomic in the case of ammonium, because remember, this is a cation that's a polyatomic. And then you're going to name the polyatomic. So for example, if I had something like this on my chart, and I said I need to name this compound, then I would name it copper sulfate. If I had something like AlNO3, then I would name it aluminum nitrate. Determine the formula, we have to determine the charge on the metal. So when we have to determine the charge, if it's a representative element, we can use a periodic table. If it's a transition metal, then we have to actually figure out the charge, and we'll do that in just 1 second. Then we find the charge on the polyatomic, and you can see the reference sheet, but I'm sure many of you guys are starting to memorize these by now. The polyatomic stays together as a party package. That's why many of you, I encourage you to write them in the parentheses until you really get the hang of polyatomics. That way, even if you don't have anything outside the parentheses, that way you realize sulfate, for example, goes everywhere as sulfate. It's very important, especially when we start chemical reactions. If sulfate goes with something different, it's going as sulfate with a different metal. And then we simply crisscross applesauce and simplify. So let's say, for example, we are given something like potassium sulfite. Let's go with sulfite. Okay, and we have to write the formula, and this is all we're given is potassium sulfite. So we know right away potassium is K. Then we look up sulfite, and sulfite is SO3. And sulfite has a 2- charge, and potassium has a +1 charge. We know the charge from our reference sheet here with the 2-, and we know the charge on potassium using our periodic table. Then when we crisscross applesauce, we have K2SO3, potassium sulfite. Let's go on to the next one here. So now, if we have a transition metal, so binary or ternary with a transition metal, this is a little different, and it can happen with binary or ternary, so you do have to pay attention. So remember, though, transition metals include the D group that we're used to with electron configuration. Also, transition metals include the F group, and those transition metals oftentimes include especially tin and lead. They oftentimes have multiple charges. So what we have to think about here is the charge on the transition metal is indicated by the Roman numeral. So we are going to use a Roman numeral here, and that is an indication of the charge, not the number of atoms. You must determine the charge on the metal first when you name with a transition metal. So, for example, let's say I have something like NiCl3. What I have to do is I have to think about here, what do I know about chlorine? Because I don't know the charge on nickel yet, but I do know the charge on chlorine is a 1-. I know that just by looking at my periodic table. I have 3 of those chlorines that are 1- each. So 3 times a 1- is an overall -3. Now I have 1 nickel here, and that 1 nickel, in order for me to get a +3 here, I'm going to have to take that 1 nickel, and it's going to have a +3 charge in order to cancel that out and make this an overall charge of 0. So also, if you notice, and this works most of the time, not all the time, but I kind of backward crisscross. So I have 1 here is my charge on chlorine, and I know it's a -1. So therefore, if I work backward, my charge on nickel must be a 3. So I write it as nickel, as my charge on nickel is a +3, so nickel 3. And then I simply write it as chloride because it is binary. So don't forget, this is binary here. Now, if I had a ternary one, let's say I had copper sulfate, and I know my charge on sulfate is a 2-. So I have 1 full sulfate, so 1 times a 2- is -2, and I have 1 copper. So what times that 1 is going to equal a +2, so I can have an overall charge of 0, and that's going to be a +2. So 1 times a +2 is a +2, so I can get my overall charge of 0. So therefore, when I go to write, I write copper, then I write my Roman numeral as my charge on copper, copper 2 sulfate. Okay. The next part, writing the formula from a transition metal. This is the easier part, so don't make this harder than what it is. Say, for example, I have something like tin, 4, oxide. So all that I have to do here is tin is Sn. That 4 is my charge, and it's already given to me. So I know that's my charge on tin. And then my charge on oxygen is 2 minus, and I know that from my periodic table. And if I crisscross, I'm going to get SN2O4. This is one of those times that I can simplify because 2 and 4 both, 2 is a multiple of 4. So I can simplify by dividing each of them by 2, which then it equals SNO2. Now here's the tricky part. If I were given SNO2 and I wanted to find my charge on tin, I would have to think about this. My charge on oxygen is a 2 minus. So 2 times a minus 2 would be a minus 4. So that's how I got the plus 4 charge on my tin. So how do I know a compound is covalent, which is totally different than the ionic compounds that we were just working with? And a covalent compound is made up of 2 or more nonmetals. So notice the nonmetals on the periodic table are the yellow, and oftentimes, well, not often, but sometimes metalloids are considered to be, and they behave the same as nonmetals, especially things like silicon, and you might see arsenic in there as well. Those two behave very much like nonmetals. We have to use prefixes for nonmetals. Don't get prefix happy and use prefixes on everything, just the nonmetals. So this is when we use the mono, di, tri, and so forth. We do want to remember for a note, there's no prefix of mono on the first element. So we never say like monocarbon, for example. We just say carbon if there's just one element, or I'm sorry, one subscript on the first element. And finally, we also notice that the least electronegative element is always written first. Remember, the most electronegative element on the periodic table is fluorine. So whenever you have a compound, we're not going to write fluorine first because that's always going to be the most electronegative element when it's compared with something else. Here's some covalent compound examples. So let's just name these here. We look at OF2. So we have one oxygen. Notice we're not writing monooxygen. We simply write oxygen. We have two Fs, so we say di for 2. And then we use our IDE suffix, oxygen difluoride. If you notice a prefix in there, you're going to know that it's a covalent compound. For N2O2, I have dinitrogen, and I also have 2 oxides, so I'm going to say dioxide. So dinitrogen, dioxide. If I want to go the other direction, I have carbon tetrachloride. So carbon, I just have 1 because I would have mono, but we don't say mono. And then tetrachloride, so I have Cl, and tetra means 4. Notice there's no charges here at all. The numbers are simply the subscripts. For carbon monoxide, I have carbon, and since it's mono, I just have 1, so I just have CO for carbon monoxide. So overall, guys, this simply takes practice, and I have lots of options here for you on Schoology to practice. So please, please, please use them. You guys can do great on this quiz. I just know it. See you later.